Now we're going to do some examples with compounding interest. Here's our formula for compounded interest a finite number of times in a year, and this is continuous compounding. So in this problem, we are given an investment of $5,000, and that is invested for 10 years, so that's our time T. The interest rate is 6.5%, and 6.5% would be expressed as 0.065, and that is our value for R. That's the interest rate. So the principal, which is the invested amount, is the $5,000, and our T equals 10. And then we have four different situations. For compounding semi-annually, N is equal to 2. Here, compounded quarterly, N is equal to 4. And compounded monthly, N is equal to 12. So every month, that's 12 times a year. Compounded continuously, we're using the other formula, which is this. And so this formula is going to be P is our 5,000. R is the 0.065, and T is 10. So plugging in these other three, we're going to use this formula because it's a finite number of compoundings. We get that our amount, A, is the principal, that's our P, times 1 plus the interest rate 0.065 divided by the number of compoundings. For this example, part A, it's 2. So we're going to take 2 times 10 in the exponent. Now when you calculate that on your calculator, you should get $9,479.19. When you compound quarterly, you're going to use the same formula, but instead of having a 2 here, you're going to have 4. So A equals 5,000 times 1 plus 0.065 divided by 4, because we're compounding quarterly, and then raised to the power of 4 times 10, which is 40. And when you calculate that, you get $9,527.79. Here, when N equals 12, we have 5,000 times 1 plus 0.065 divided by 12, raised to the power of 12 times 10, that's going to be 120. Plugging that into our calculator, we get $9,577.70. And finally, to do this calculation, we're going to use the E function in your calculator. And you're going to get your amount is equal to, I'm sorry, I used this number here. That's actually meant, I was looking at the wrong number. So it's $9,577.70. And this number, I copied it wrong, is actually going to be $9,560.92. Okay, got that right now. All right, now looking at these numbers, you'll see that they increase quite a bit going from 2 to 4, okay? It jumps up from 9,479 to 9,527, so that's a pretty good jump. But going from this number here to the next one, it's not quite as big of a jump, and even less as we go from compounding monthly to compounding continuously. There's only an increase of about not quite $17. Okay, so it kind of levels off is the point here. So you would think that compounded continuously, you'd make tons and tons of money. And yes, you do make more, but not as much as you would think, going from monthly to continuous compounding. So that's something to note there.